Okay, in this worksheet, we're going to be looking at power. And quick reminder, power is defined as the rate at which work is done, so work divided by time. But remember, we also have a couple other equations for it. Since work is the force times the displacement, we can take the force times the displacement and divide that by time as well. And then a quick reminder, the distance over time, that's also equal to velocity. So we can say that power is also equal to the force times the average velocity. So a couple different equations we get an opportunity to use. So let's start with number one. It says a student weighing 500 newtons. So we know the force exerted because in order to lift himself up, he's going to have to exert at least his body weight, so 500 newtons. And he raises his body 0.3 meters. So we know the distance going up is going to be 0.3 meters. And then it says that it takes 1.5 seconds in order to do so. So you're looking for the amount of work done. So remember from before, work done is equal to force times the displacement. So the 500 newtons times the 0.3 meters. And when I get that, I get a 150 newton meters, or more commonly known as joules. Then if I want to find the student's power, we go back to our original, and I'll put this in orange, that power is equal to the work divided by the time. So I take that 150 joules, divided by the 1.5 seconds, and I end up with 100 joules per second. But remember, that's also known as a watt. Okay, quick reminder, and we talked about this in the Nearpod, but remember that this W, and I'll circle it here in purple, that this W behind the number stands for watts, and this number right, or this W right here stands for work. And so if it's a number followed by a W, it's the unit of watts. If it's just the W in the equation, then it's going to be work. Okay, so if we look at number two, it asks how much work can a 125 watt motor do in 2.5 seconds? So again, using our guess method, and we'll go green here just for fun, is that our work done is what we're looking for. The power is equal to 125 watts, and my time is equal to 2.5 seconds. And so remembering that power is equal to work over time, I can say that 125 watts is equal to the work divided by the 2.5 seconds. So when I cross multiply, I'm going to get 1,000. So W is equal to the work done is 1,312.5 joules. Or you can put watt seconds. That is perfectly fine as well. Okay, number three, we have a force because it's an 8,000 Newton elevator. So the 8,000 Newton elevator, that talks about the force of gravity pulling it down. So if that's 8,000, in order to lift it up, we're going to have to exert a force up of 8,000 as well. So my force that I'm going to exert is 8,000 newtons, and it's going to go up at a speed of 0.3 meters per second. What's the power of the motor? So remember that power, this is one of our offshoot ones, power is equal to force times velocity. So power is the force times the average velocity. So 8,000 newtons is what's being exerted. Newtons, I keep writing this as a W. And then I'm going to multiply that by 0.3 meters per second. And so that's going to give me a whopping 2,400 watts. You could also have Newton meters per second, and that'd be perfectly fine as well. Okay, next one. An operator of a plate system exerts a force of 80 newtons. So we know the force exerted is 80 newtons. We know a distance of 12 meters is how far he's going to exert that. And he's going to do that over a time period of 8 seconds. And so if I want to find the power, remember, is equal to the force times the displacement divided by the time. So our force is 80 newtons times our displacement of 12 meters. And divide that by our 8 seconds. And we should end up with a whopping 120 watts for that. Okay, the 80 times 12 divided by the 8. Number 5, they give us the power. So I'll put this in blue just for something different. The power is equal to 300 watts. And then we know the force exerted is going to be 100 newtons. And we're looking for the speed. So it's the exact same equation we used in number 3. You know, power is equal to force times velocity, except now our power is 300 watts. The force exerted is 100 newtons. And looking for the average velocity. So my average velocity is going to be a whopping 3 meters per second. Okay, number 6. An airplane weighs 20,000 newtons. Is designed to gain altitude at a rate of 10 meters per second. What's the minimum power? So we also have the force is going to be 20,000 newtons. Again, because that's its weight, so the force exerted on it has to lift it up. It's got to be equal to the least weight to the weight. And we know the average velocity is 10 meters per second. And so power is equal to force times the average velocity. So you end up with 200,000 watts. Or you could say 2 times 10 to the 5th. That would also work as well. All right, and our last one, number 7, we have a worker pulling out a crate, and we'll go to purple for this one. Across warehouse 4, the force of 200 newtons. So we have a force of 200 newtons. Apply to the rope, pulls the crate 20 meters. So we know the distance is going to be 20 meters. And then we know the time is 28 seconds. And we're looking for the power generated. So power, remember, is force times the distance divided by the time. And so my force applied, 200 newtons. The distance, 20 meters. And then I'm going to divide that by my 28 seconds. And I'm going to get a power of 142.9 watts. And once again, I could leave that as Newton meters per second and be perfectly right. So, hope that helps. If you have any questions, again, come see me. All right? Have a great night. Bye.